hearty welcome to You Too Can, a channel that will help you to succeed in examinations easily.
Now let us see another type of problem is in RC transients. Okay, in the circuit shown in figure, the switch S is in position 1 for a long time. This is switch and it is in position 1 for a long time, and it is thrown to position 2. You have to find the transient current. So the switch is now thrown to position 2 after a long time when it is at position 1. So the circuit will be like this when it is at second position, and the capacitor is charged to a value when it is at first position. So you have to find the previously charged voltage across the capacitor when it is at first position, and write the KVL equations for the second position and find the transient current. This is the procedure. Okay. So when it is at first position the circuit will be like this. That is 50 volt, 50 ohm, 100 microfarad capacitor. So this is the connection of the first position circuit. Okay. Now a current flows through the circuit and a voltage is developed across this capacitor. We all know that the voltage across the capacitor is V into 1 minus e power minus t by RC. Okay. Now substitute the values of voltage. 50 into 1 minus e power minus t divided by r is 50 into 10 power minus 6. Okay, and now the switch is then transferred to position 2 after a long time. So after a long time means t is taken as infinity. So Vc of infinity is 50 into 1 minus e power minus infinity. This will be equal to 0. So it is 50 volt. Okay. So initially, if there is any no voltage or it is in relaxed condition, means this supply voltage is applied across the capacitor, and the capacitor is initially charged to the supply voltage 50 volt. So the initial voltage across the capacitor now is 50 volt. Now the switch is transferred to second position. In the second position, the circuit will be like this: 25 volt, 50 ohm, 100 microfarad, and this capacitor is initially charged to a voltage of 50 volt in this direction, plus minus. Here also plus minus means here also it is charged in this polarity, plus minus. Now you have to find the transient current. Okay, now write the KVL equations as you all know. KVL equations: 50 I of t plus 1 by 100 microfarad, 100 into 10 power minus 6, integral minus infinity to t I of t dt will be equal to 25 volt. Okay, now 50 I of t, what is 1 by 100 into 10 power minus 6? 100 into 10 power minus 6 is 10 power minus 4. It will be 10 power plus 4, and this interval is split into two intervals. That is, one is minus infinity to 0 I of t dt plus 10 power 4 0 to t I of t dt, which is equal to 25. This voltage, that is 1 by c integral minus infinity to 0, is taken as a previous voltage. Here the previous voltage is assumed to be 50 volt. Okay, so 50 I of t plus 50 plus 10 power 4 integral 0 to t I of t dt will be equal to 25. Okay, so 50 I of t plus 10 power 4 0 to t I of t dt will be equal to 25 minus 50. So 50 I of t plus 10 power 4 integral 0 to t I of t dt will be equal to minus 25. Now apply Laplace at this stage. Okay, so After applying Laplace, it will become 50 I of s plus 10 power 4 I of s by s and minus 25 by s. Okay, so I of s is taken outside. 50 plus 10 power 4 by s equal to minus 25 by s. Okay, I of s, take LCM, 50s plus 10 power 4 by s will be equal to minus 25 by s. S gets cancelled. So I of s is equal to minus 25 divided by 50s plus 10 power 4. That will be minus 25. Take this 50 outside. S plus 10 power 4 by 50. That will be minus 1 by 2. Minus 1 by 2 is minus 0.5 divided by 10 power 4 divided by 50 will be 200. So S plus 200. So I of s is equal to minus 0.5 by s plus 200, and taking Laplace inverse, then find I of t will be equal to minus 0.5 e power minus 200t. This is the transient current through the capacitor when it is switched to second position after a long time. Okay, hope you have understood it. Thank you.
Thanks for watching this video. Wish you all the best.